Good morning to all. Today we are starting with the steroids, terpenoids, and even the cardiac glycosides and saponins, and how they are related and how their chemical structures have interrelationship, and also some few drugs like Dioscorea digitalis, purpurea digitalis, leneta, and we want to see about licorice, very important drug which is very commonly used in our traditional Ayurveda preparations, and even it has more applications in various ailments. And anyhow, we are going to discuss about our basic knowledge regarding steroids and terpenoids and glycosides, specifically cardiac glycosides and saponin glycosides, and their chemical tests. All these things we are going to discuss, and we may be doing this in 2 hours. That means today one class, and the next class we will be continuing the same chapter. So now we will start, as I told in the introduction, that is, we are going to discuss about steroids, cardiac glycosides, triterpenoids, in which today we are going to see Dioscorea. But still, Dioscorea is an saponin glycosides. Apart from cardiac glycosides, I should have mentioned even saponin glycosides in the heading, because Dioscorea is a saponin glycoside actually. According to the syllabus we are going, that's why it's written like that. And even we will discuss about saponin glycosides also. In this topic I should have added regarding saponin glycosides also in the headline. Anyhow, it is just in the preparation I missed it to write down. So anyway, we can see inside the material, you can see very clearly. And now you see triterpenoids. Terpenoids we have already discussed in our biosynthetic pathways. We have discussed that is mainly in acetyl pathway, mevalonate pathway, vindet and all. We have seen very clearly we have 5-membered carbon atom compound, which is isoprene unit, which is the main unit block or the primary units of terpenes, and they are called as, that is 5-member, that is pentyl pyrophosphate, dimethyl allyl pyrophosphate, which forms squalene by means of making into 10-membered carbon atom geranyl pyrophosphate, and geranyl pyrophosphate will be converted into farnesyl pyrophosphate. 2 molecules of farnesyl pyrophosphate can be converted into squalene, and squalene is giving rise to dihydrolanosterol, and that is giving cholesterol, which is a steroidal ring structure, which is the basic phenanthrene 6-membered ring structure with the 5-membered ring structure attached. Even the numbering, everything is important for you to remember what you studied in steroids. And also the terpenes, we have discussed about terpenes, monoterpene, diterpene, triterpene, sesquiterpenes. These terpenes are also, most of them, having similar extended structure similar to the steroidal structures, and they have even the linkage with sugar moiety, like then they will give glycosides. So these all things which we are going to see about this structural comparison and their relationship. And now you see, triterpenoids are compounds with a carbon skeleton possessing 6 isoprene units. You know that 2 isoprene unit, when it is 10 carbon atom, that is for example geranyl pyrophosphate, 10 carbon atom, we can say monoterpene. Understand? So 6 isoprene units means you may imagine how much 6 into 5, 30 carbon atoms will be there, which are biogenetically derived from squalene. Squalene is an acyclic carbon containing 30 hydrocarbons, which we know very clearly. You have to remember whatever we have studied before, also you have to recall and you have to study the material. Then it will be easy for the students to remember and to appear in the examination. They are generally complex cyclic structures of alcohols, aldehydes or carboxylic acids. They generally have high melting point and optically active. So they have chiral carbon atom, they have their own rotation, the molecules, when a plain polarized light fall on them, so they have optical rotation. So that also you should know. So they have isomers, configurations will be there in these compounds. So they generally have high melting point and optically active. Along with these, they are colorless compounds which are crystalline in nature. These compounds are hard to categorize because of their less chemical reactivity. The Lieberman-Bouchard's reagent, Lieberman-Bouchard test is a very important test for any steroidal and terpenoids. So you can see the Lieberman-Bouchard reagent contain what? Acetic anhydride with concentrated sulfuric acid. So you have to use always, whenever you are using the word acetic anhydride or any chemical name, any names, immediately the student should remember the structure of the compound should come in an imaginary picture. Then only you can be thorough with the chemistry. You know, acetic acid, everybody knows, CH3COOH. Acetic anhydride means 2 molecules of acetic acid, removal of 1 water, you will get the acetic anhydride. Hydrate molecule is taken. They are very explosive and it is very important chemical which is have to be restricted chemical. In our laboratory we used to have account maintenance for these chemicals, even like acetic anhydride, methanol, chlorates, these and all, we are just keeping records for them to be usage of them in the chemicals should be maintained. So acetic anhydride with concentrated sulfuric acid produce bluish green color with terpenes and sterols. Sterols means OH group, OL, you know, alls. Al means aldehyde, OL means alcohol. Sterols which contain alcoholic groups, that is why they are called sterols. Steroids can be called as sterols. Even naturally available, they can called as sterols, the steroids. So triterpenoids comprises 4 groups of compounds. 1. True triterpenes. 2. Steroids. 3. Saponins. 4. Cardiac glycosides. So that's why I told saponin glycosides. I did not mention in the topic headline in the material. It is needed to be added also. It comes along with the steroid and the terpenes. Some triterpenes are well known and newer compounds are regularly being discovered and characterized. Alpha amyrin and beta amyrin and their derived acids, uracilic and olenolic acid are some example of pentacyclic triterpenes which exist in nature widely. So these compounds occur in the waxy coating of the leaf, fruit like apple and pear. They may have protective function in insects, repelling and microbial attack. They are giving protective measures for the fruits and the leaf. Some triterpenes, euphorbia, hava, etc. are found in resins, bark of trees and in latex also. So these all are some of the things which you should know, that secondary metabolites which are used by the plant for their protective nature or protectiveness, or they can protect themselves from the predators. So you see the alpha amyrin, beta amyrin, gamma cytosterol structure. This alpha amyrin and beta amyrin, you see there is 3 phenandrine ring structure. The 4th one and the 5th one are also 6-membered ring structure for alpha amyrin and beta amyrin. Only thing is the CH3, the annular CH3 group have been shifted from one point to another, that is beta amyrin and alpha amyrin. The position is differ, but other the formula is similar. That is why they are alpha amyrin and beta amyrin they have mentioned. But you see the gamma cytosterol, the name came because it has a similar structure of cholesterol. So you have to think about the previous chapters and your basic structure of a cholesterol. Every student should have their imaginary in their mind. Then only you can remember this structure. By seeing the structure, you should not think it's a very complex. It's a very, very simplest structure which we can write very easily. Once you write phenandrine and then the substitution of two 6-membered ring, you are achieving beta amyrin. Once you write cholesterol and if you go for in 23 position, if you write 2CH3, CH3, you will get this gamma cytosterol, because it is same like the cholesterol structure. OH is there, a double bond, dihydro double bond in the second ring is there, annular methyl groups are there. Understand, only thing is to methyl groups 3 carbon atoms you have to add in the cholesterol, and so that you can achieve gamma cytosterol. So you want to know about these all are some of the terpenes you have to remember and in the nature. And now I have just brought you to make you to think that how to remember this cholesterol structure which we have studied before, or you might have studied in your chemistry also, and also in the production of cholesterol by means of acetate pathway we have seen in our basic metabolic pathways when we have studied in the previous classes. So see, cholesterol, it has 27 carbon atom, 46 hydrogen, and that is OH group is present in the 3rd position. So you can remember, in this place you have to remember the 17th position of the 5-membered ring structure, and also the 24th position and the 23 position and 21 position, you will be always seeing some attachments and substituents which makes various compound in what we are going to see now in the basic triterpenes and steroids, steroidal compounds, and even saponin. Saponin is also the same basic ring structure. So a steroid will have A, B, C, which is the phenanthrene ring structure, which 3 6-membered ring, and a B with a 5-membered ring structure. Then this 5-membered ring structure, the 17th position, will be attached with various substituents. Even in cardiac glycosides, you can find out there will be some lactone rings will be attached in the 17th position, will change the structure. So if you know the numbering and if you know the basic structure of this compound, it will be easy for you to write the structure, and also to explain about the structure will be easy for you. So dear students, you have to always have a basic idea about the basic chemistry. Always whatever we have studied before, it should come in your mind, or you have to go for the reference in the studies. And now you are coming to the sterols and triterpenes contain cyclopentane perhydrophenanthrene ring. What is that? So a phenanthrene ring means 3 6-membered ring, and a cyclopentane, that means 5-membered ring is attached. That is what the name, very clearly you can write. If you see the structure and if you know the chemical name, you can write it as well as you can remember very easily. Cyclopentane perhydro, that is a bond, phenanthrene ring. The 3 phytosterols, that is sitosterol, also known as beta sitosterol, stigmosterol and camphosterol, occurs in higher plants abundantly. These sterols occurs in free form and as simple glycosides. Some examples of less common sterols are alpha spinosterol, found in Spanish, alpha and senega. These are the plants which is very commonly used. Now alpha is very common plant, which is nutrition plants. Actually it is grown in like a waste plant, and it was used for the cattle actually. Now we have found out what is the basic, because it has more effect when it is given for horse, the power. Then they understood it has more vitamins and power in these type of plants which contain glycosides, which have glucose molecules attached with an A-glycan, which has medicinal use, as well as vitamins are also present in them. And ergosterol, found in yeast and fungi, is also a sterol which is present naturally. Phycosterol, found in brown algae and in coconut, which is available. So see the structure: beta sitosterol, basic cholesterol structure. There is no, only in the 24th position you have one CH2 and a CH3, and when you see in the camphosterol, you can see there is one CH3 is removed from the 24 position. When I say 24 position, you should know, you should remember the previous slide which I showed. The cholesterol 24, 27, 26 is the last stage of that Y shape, and you can see there is it starts from 17th position of the cyclopentose structure, the 5-membered ring structure, A, B, C, B, D, the 6th structure, that is a side chain. So in the side chain there is a change in the carbon atom, gives the molecule very clearly to write. And stigmasterol, you see, stigmasterol, you got a double bond, that means a addition of, or removal of hydrogen, dihydro, double bond is coming means you are removing hydrogen. So when you are removing hydrogen, then it is called stigmasterol. And now we are coming to saponins. I told saponins are also having relation with the sterol and with terpenes, steroids and terpenes. Saponins are glycosides of triterpenes and sterols. Triterpenes and sterols occurs in more than 70 families of plants. 70 families of plants. They have soap-like property and act as a surface acting agent or surface active agent. You might have studied in your pharmaceutics, surface acting agent means what? You might have studied about twin 80, twin 60 and tragaganth, acacia. These all are tragaganth, especially you are using as an emulsifying agent twin 80. What it will do? Surface acting agent. They will reduce the interfacial tension and makes one compound to be dispersed in other by reducing the interfacial tension, reducing the surface tension. So surface acting agents, this is also surface acting agent which forms soap. They have the ability to hemolysis of the blood cells. Even a chemical test also they used to do. When you add a saponin, it will lysis, that is red blood cells will be broken, it will be lysis, hemolysis. So that can also be used as an identification test for saponin. And few examples of saponins are hecogenin from agave, is a plant, I will show in the next slide. It's a very common, it looks like an aloe vera, but it is not aloe vera, it is a different variety. It is little bigger than which the plant which are available here. And imogenin from Dioscorea species. Saponins, there are few saponins from alfalfa, that is hydrogenin and medicagenic acid, that structure also written there, and glycyrrhizin from licorice root, very commonly which we are used as a drug in Ayurveda and Siddha and various our traditional medicine we are using. Licorice not only as a sweetening agent, it is called Adimaduram in Malayalam. And it is very commonly used in Ayurveda, Siddha and various traditional medicine practice. And saponin, when it is undergo hydrolysis, it will be, because it is a glycoside, so a glucose molecule and a glycan part will be removed and also a glycan part. A glycan part, you can see sugars of glucose, arabinose, xylose and gluconic acid can be also formed by the hydrolysis, and in A glycan can give rise to sapogenin, neutral saponin and acid saponin, and neutral saponin can give rise to steroids and acid saponin can give rise to triterpenoids. So from this it is very clear for the student that is saponin glycosides will have a complicated structure along with steroid and a triterpene base structure with a glucose molecule or a carbohydrate moiety or a sugar moiety will be there, as it is in glycosidal linkage. And now this is just to show you the picture of this hecogenin. We have written there, it is present in agave plant. See the plant, it looks like aloe vera, but it is very pointed, which is very needed, which is little dense, same variety, but it is agave, the plant which contains this hecogenin saponin. And hemogenin is present in Dioscorea species. Dioscorea species, it's always we are tumors, and the rhizomes are always used from Dioscorea species. Even some of them are edible also, very few varieties. Even you may be knowing when you see some varieties when I show in the Dioscorea species, you can find whether it is present in our home or in the hometown which they are using it. It's very good when you compare your studies with your normal life, and so that you can remember. Practical makes the student to remember in the whole time, not only for just for the examination purpose, it will be in his life. These are subject which is needed for your normal life. These are subject which needs, the knowledge is needed for your complete service of as a pharmacist and to serve the mankind, to help them. So you should know what is the use of various medicinal plants and what is the use of the various medicinal plants which are normally used by us as a food and as well as for the various purposes. Saponins have occasional toxicity in cattle and possess sweet taste, so they are economically beneficial. The glycosodic pattern or the glycosodic linkage of the saponins are quite complex. They have as many as 5 sugar units attached, and gluconic acid is present in them. You see some of the examples even we have taken. Hecogenin is the structure which we have just seen, that is, it is the present in the plant which we have seen now, this one, agave. And there you can see hecogenin and hemogenin, which is present in Dioscorea, which we'll see in detail about the plant, Dioscorea, and glycerin is present in the licorice root. So see this structure, it is a basic structure of the ring. That is phenanthrene ring structure, 3 6-membered and 1 5-membered cyclopentanone structure, which is connected with 2 lactone ring, 1 5-membered lactone ring and 1 6-membered lactone ring. Hecogenin and hemogenin are almost having the same structure. Only thing is the CH3 is added 1 more in the 6-membered lactone ring, and there is a double bond O in the ring C, A, B, C, 6-membered ring in the phenanthrene ring structure in hecogenin. Hemogenin, you are not having that double bond O. So you can remember. And you see here in glycyrrhizin is a main component present in Glycyrrhiza glabra. That means glycyrrhizin in licorice root, botanical name is Glycyrrhiza glabra. And you see this glycyrrhizin is an acid, actually glyceric acid, which has a phenanthrene ring and 2 benzene rings are attached in the naphthalene group in the cyclopentanoate area, and there is an acid group. You can see the functional group which is glycerin. So glycerin is also a triterpene unit. More than 30 carbon atom is present in them. So that's why it is called triterpene units. We are not telling simply terpenoids. We are selling triterpene units. That is why we use triterpene units. Please remember this one. Understand? Don't get confused. Why it is used triterpene units? Why you cannot use? You can use terpenoid, but simply you should remember that it is having more than 30 carbon atoms. That is what we have to see. That is, there is having 6 isoprene units will be there. Understand? So it will be easy for you to remember when you know these basic things of the structure when you are studying. It is easy for you to write and to impress the examiner when you write an exam paper. And now you see the alpha is, as I told, alfalfa is a plant, very common, and also it is very commonly used as a horse actually. Horse they were used, and also cattle feed they used to give this one, and it can be sprouted one. They are powdered, and in the market you have powder of alfalfa. You can see in the internet also, you can see in the market what is the use of it, what is the vitamins present in them, and how they are using now. It is very commonly grown everywhere. Understand? And also you can see it contained, we told it contained 2 saponin glycosides, which are heterogenin and medicogenic acid. So what is the difference, heterogenin and medicogenic acid? They are also having the similar structural formula of the licorice, what you have seen just now, that is the glycerin structure. Only thing is they have 2 methyl group in the end of the 6-member ring structure. They have how many ring structure? They have nearly 5 ring structure, 6-member ring structure. And they have this, what is the difference between them? You can see that this is acid and this is OH group, alcoholic group. That is why it is genin, it is an A-glycan part, and again that OH group will be linked with an carbohydrate moiety, and it will make a saponin glycoside. So heterogenin and medicogenic acid are the common saponin glycoside genin part which is present in alfalfa. And now we can see the chemical test for saponin glycosides. Chemical test for saponin glycosides, as I told in the beginning in the explanation itself, hemolysis test, a drop of blood or a drop blood on a slide is kept, was mixed with a drop of aqueous saponin solution. What will happen? The RBC becomes ruptured in the presence of saponins. So this is an test which can be done for saponin glycoside. Simple test can be done for a saponin glycoside. Foam test. Foam, as I told you, they are surface acting agent. Even we discussed about surface acting agent. They will reduce the interfacial tension. They will reduce the surface tension. They will act as they will form foaming. So we just talked about even emulsifying agent, suspending agent, TNAT, Tragagan, these all example just before I just discussed with you. So you can use that test also. So foam test, to 1 gram of the drug, that is saponin glycoside, add 10 to 20 ml of water, shake for few minutes, formation of frothing which persists for 60 to 120 seconds denotes that presence of saponins. And next we are coming to the last group, which is very important group coming in the triterpenoids, are cardiac glycosides or cardinolides. They can say even bufenolides, another one, derivatives also there in cardiac glycosides. But usually we used to say cardiac glycosides because they are used for cardiac congestive failure, and if it is very critical situation, it is the only drug of choice which can be obtained from the nature, can help the whole ailment of this cardiac muscle strength. As a general rule, the glycosides are fairly soluble in water and slightly soluble in ethanol and chloroform. The lactone ring, we talked about the lactone ring previously. There is 6-membered lactone ring, 5-membered lactone ring, together it is mixed, which has been, we have seen there before. So these lactone rings plays a major role in the presence of the steroidal ring structure in the cyclopentanone structure 17th position. If you have a lactone ring, they are becoming cardiac glycosides. You just cardiac glycoside or cardiac glycoside gerine part. So that is what we are going to discuss. So lactone ring with a ring which have an O group, lactone, 6-membered lactone ring, 5-membered lactone ring. Students should be clear with that in this degree level. Understand? So it's very simple points which I am just repeating. If you know, it's well and good. Lactone ring likely to open in an alkaline medium. The cardiac glycosides are mainly divided into 2 groups. One is cardenolides, number 2 biphenolides. Chemically, the aglycan part of cardiac glycosides is a steroidal moiety. They are either C23 or C24 steroids. So it is short, it is not C27 like cholesterol, it is short. Understand? C23 or C24. C23 means 5-membered lactone ring. C24 means 6-membered lactone ring. Very simple. Because of either 5-membered or 6-membered lactone ring respectively. Those with 5-membered lactone ring are called as cardenolides, while with 6-membered lactone ring are termed as biphenolides. Very simple. Understand? And the lactone ring of cardenolide contains only one double bond and is attached to steroidal nucleus through carbon 17. That is why I told, see that 17 number carbon atom which is present in the 5-membered ring structure, which is called cyclopentanone, attached with the phenanthrene ring structure in a steroidal moiety. You remember the cholesterol structure which I have shown, and you can remember that carbon 17 position. And in biphenolides, the lactone ring contains 2 double bonds and is attached to the steroidal nucleus through 17 beta position. 17 beta position. Carbon 17 beta position. Now you see, if you see this structure, the formation of the lactone ring, presence of lactone ring, how cardiac glycosides is differentiated into 2 type or classified into 2 type by means of the presence of lactone ring, 6-membered and a 5-membered ring structure. Can you see that cardenolides versus biphenolides? Cardenolides, it contains 5-membered ring in the butyrollactone ring as shown there, and biphenolides, it consists of 6-membered ring. It is a pyrrone ring structure. You can see 6-membered with 1 O. And so you can see how it is formed. In the 17th position of the cyclopentanone ring structure, you can see that steroidal ring structure in the biphenolides. There it is attached to that 6-membered ring structure, that is called biphenolide. And cardenolide, you see, it is having 5-membered ring structure with one single bond inside, and here it is two bonds are present in the six-membered ring structure. And you can see here the two structures also even given. Sugar moiety will be attached with the OH group which is present in the third carbon atom of the A structure, A, B, C, D. We have seen the steroidal structure of the cholesterol. In that A structure, OH, that O will be attached with the sugar moiety and it will give an cardiac glycoside or cardinolide. When it is having six-membered ring structure, then it is called biphenolide. When it is having five-membered ring structure, then it is called cardinolides of the cardiac glycosides. I hope this slide makes you clear that what is the difference between a cardinolide and a biphenolide comes under in cardiac glycosides. Only difference is presence of their lactone ring. If there is in the 17th position of the ring structure, if there is a five-membered lactone ring, then it is called as cardinolide. If there is six-membered lactone ring, then it is called biphenolides. Very simple to understand this part. And now we are coming to extraction and isolation. This is also very simple experiment which can be carried out in general. But when you go to some certain plants experiment, when you are doing specific plants, the procedure will be slightly different. Understand, we have to add various chemicals and even some procedures might be slightly changed. But this is general procedure. If you know that, anywhere if you forget also, you can maintain this general procedure for any type of extraction, isolation and characterization. How they are doing in the natural source is very important for the student. So extraction procedure for triterpenes, how they will do, dry the drug or dried powdered drug you take and defat them with ether. Defatting, last class itself we have studied, defatting is very important. Low polar solvent like hexane, petroleum ether can be used for defatting. So by ether you can defat, remove the fat which is not needed for us for the experiment. We are interested to see only about the triterpenes. So remove the fats, extract with hot methanol. You can go for continuous hot percolation method. Methanolic extract, concentrate it, use Soxhlet apparatus and then you concentrate the extract which you got. Add inorganic acid, hydrochloric acid, sulfuric acid, according to the material which you want to add, you can add and you will liberate. There you will get the liberation of A-glycan or hydroxylate you will get. So isolate, then you isolate the compound by TLC, that is thin layer chromatography. You have to come across, you have to study about this chromatographic technique, that you can see chromatographic technique which is used for separating mixture of compound. This is TLC, means thin layer chromatography. So thin layer chromatography we are using by silica gel G. In solvent system they can use, because there will be a mobile solvent and a stationary, it will be moving through the mobile solvent which will have the capacity to separate the mixture of compounds, and so we have to use some various polarity change and various mixtures of solvents has to be used as a mobile solvent. So we have seen some example. This may change according to the temperature and according to the condition of the environment. We have to change according to the trial and error method. This is just examples we have given which we can use, such that hexane is to ethyl acetate 1:1 or chloroform is to methanol 10:1 or N-butanol 2 normal. Ammonium hydroxide can also be used in the ratio of 10:1. And then after doing this separation, the compound isolated, compound separated can be characterized. What do you mean by characterization? Elucidation, identification of the structure can be done by spectroscopy method. What do you mean by spectroscopy method? There are many. last class also I have told from the beginning. I am telling every time you are telling. So you have to know that what is spectroscopy. Not only the UV spectroscopy or colorimetry, it is not only. You have UV spectroscopy, you have NMR spectroscopy, nuclear magnetic spectroscopy, which can give rise to carbon, hydrogen can be identified. Mass numbers can be identified by mass spectroscopy. And there are many spectroscopy which is connected with gas MS. That means gas chromatography, which is connected with mass spectroscopy. So there are many spectroscopy, emission spectroscopy. So there many spectroscopies can be IR spectroscopy, infrared spectroscopy, which can give functional groups can be identified. So by that, characterization or structural elucidation can be done after extraction. So that is why we are giving the heading extraction and isolation. So you have to mention very clearly, this is not only simply extraction, it is an extraction, isolation and characterization procedure. And now chemical test for triterpenoid and steroids. Lieberman-Bouchard test. Lieberman-Bouchard means immediately you will remember in the slide we have discussed that it is having, what is that? It is having acetic acid. I told what is the acetic acid? It is acetic anhydride. Two molecules of acetic acid, when you remove the water molecule, it will give acetic anhydride. We are using this acetic anhydride. So the extract is boiled with acetic anhydride few ml and cooled, and then concentrated sulfuric acid is added from the sides of the test tube. You will get, precaution should be taken during adding, because sometimes bumping may take place, it may come to your face. So you should be very careful with the test tube, and a brown ring will be formed at the junction of two liquids. A brown ring will be formed in the junction of two liquids. Especially we are doing extraction by means of a non-aqueous solvent. So that's why when you add an aqueous solvent, there will be two layers. So you can see a brown ring test, which is Lieberman-Bouchard test, can be obtained. The upper layer turns green due to the presence of steroids, and a deep red color develops, indicating presence of triterpenoids. So triterpenoid and the steroids can be identified, and you can explain very clearly they both are together present in them. That is why this deep red color is develops due to the terpenoids, and a green color is the upper layer is due to the presence of steroids. So both of them can be identified by Lieberman-Bouchard test. And Salk-Oxy test, when extract is treated with concentrated sulfuric acid few drops, when you add, a red color develops in the lower area and in the presence of steroids. So yellow color develops, indicates the presence of triterpenoid. So you can see, or if it is yellow color, then it is triterpenoids. If it is, you can see that red color, then it is called steroids. So like that you can differentiate them. Sulfur powder test, adding sulfur powder. It was test, sulfur powder is added to the test solution, which sinks at the bottom to the test tube. Otherwise sulfur powder will be just floating. It is fluffy powder which will be float. So when it sinks, it indicates the presence of phytoconstituents. That also a simple test can be carried out. Now we are coming to extraction procedure for cardiac glycosides. It's also a simple procedure which we can do. First, powdered drug. Extraction with 50% ethanol at low temperature. Add lead acetate solution. Why you want to add lead acetate solution here? To remove the impurities, to precipitate the tannins and remove the impurities, and then you centrifuge and remove all the precipitate out, and then supernatant liquid is taken, and then you extract with chloroform. The chloroform extract is evaporated for dryness, the residue, it will become residue. Cardiac glycoside is present in that residue, and then you are purifying this by means of chromatography. We can use any chromatography, and then you can separate the compounds. Then you are characterization by means of spectroscopic method. So you should know that extraction, then separation by chromatographic technique, Then characterization, structural elucidation by spectroscopy method. Spectroscopy means you have to remember UV spectroscopy, IR spectroscopy, NMR spectroscopy, mass spectroscopy, emission spectroscopy, and there are many other techniques which can be used for to identify and to elucidate the structural formula, and that is called characterization of a compound. Can be done in the chemistry, natural chemistry. And now we are coming to the chemical test for cardiac glycosides. What are the chemical test for cardiac glycosides? Number 1, Baljet reaction. When test solution is treated with picric acid or sodium picrate, yields a stable orange color. These reactions are negative with saponin and either negative or much weaker with biphenolides. Especially biphenolides, what is the lactone ring present in biphenolides? What is the lactone ring is present in the biphenolides? 6-membered ring is present and it is biphenolides. So you can see that is next one is Raymond test. When test solution is added in hot methanolic alkali solution, a violet color is developed. Legal test for cardiac glycosides. When aqueous or alcoholic extract is treated with pyridine 1 ml and sodium nitroprusside 1 ml solution, pink to red color appears. Killer-Kilani test is a very important test. Even the identification, even 2-mark question or 5-mark question, they will ask directly the chemical test for cardiac glycosides, and they used Killer-Kilani test. They will expect you whether you are writing it or not very clearly. You have to write and you have to study without any chemical missing. It's very easy. Take chloroform extract from the drug and dry it. Then add glacial acetic acid 0.4 ml along with trace of ferric chloride. Transfer the content to a small test tube and add concentrated sulfuric acid 0.5 ml by the side walls of the test tube. Acetic acid solution turns slowly blue-green in color, indicates the presence of deoxy sugars. Digitoxygenin, digitoxin are present. Deoxy sugars presence can be identified. What can be identified by the Killer-Kilani test in cardiac glycosides? It can identify deoxy sugars which are present in the glycosides. Xanthidrol test. When extract is heated with xanthidrol solution 5% in glacial acetic acid and hydrochloric acid 1%, a red color develops, indicates the presence of 2-deoxy sugar. These are our new test which appears. And antimony trichloride test. Add antimony trichloride and trichloroacetic acid in a solution of glycoside or solution of the test solution. Heat the solution. Blue or violet color appears, indicate the presence of cardenolides and biphenolides. Now we are coming to today's class. Only one drug I am going to teach about the digitalis and licorice. We will see in the next class. Dioscorea we have taken as an example today. Dioscorea, you have to remember that is a saponin glycoside. Dioscorea, this you can see the picture. Dioscorea compositae, Dioscorea tocota is there. The leaf structures are different. Even their rhizomes are also slightly differ in one species actually. Dioscorea deltoidea. These all are having component. They are not. They are substituent. We cannot say they are adulterant. Adulterant means they may not have the constituent. They have the constituents, but upside down, less or more, and the species are little difference in their leaf structure and in their color of the leaf and the morphological character and microscopical character, and even their rhizomes are also having some difference in the external structural also we can identify. So now we have taken Dioscorea synonym YAM, YAM, you can say botanical or biological source Part which is used is dried rhizome. Plant Dioscorea compositae, Dioscorea deltoides and Dioscorea tocora. Family Dioscoreaceae. Dioscoreaceae, easy to remember. Dioscoreaceae. When you write a botanical source or a biological source, if you write the part which is used and the name, the biological, that is the botanical name and the family, then only the complete definition is there. And what is the geographical source of this Dioscorea? Dioscorea is found in North America, Japan, China, Mexico, India and Nepal. In India, the plant grows widely in Western Himalaya, Karnataka, Kashmir, West Bengal and even in Kerala we have. And microscopy, color is slightly brown, the rhizome, and odor is odorless, taste is bitter and acrid. Size varies according to the species and the cultivation depending on the age of the rhizome. It may be big and the size, the tubers. See, this is Dioscorea teldotea, that means teldotea, you can say. This is very common, even in Kerala also we have available this one. You see that it looks like, which we are not the edible one, it having some similarity like potato, but not potato. Potato is round in shape, and there are sweet potatoes which also having different sizes, shapes are also available, but not that one. That is different. And Dioscorea compositae, you see darker, the leaves are very dark green in color, and the shape also, it is little bigger and larger and curved rhizomes. And you see Dioscorea bulbifera, this is also having some fruit like this, and the rhizomes are also little small, not very big. And in Malayalam we can say that is pannikilangu, or you can say even kachil, or sometimes you are saying kachlu, or even say there are many places different pronunciation will be there, but I don't think it is not always used as a very edible plant or something, but it is available even. So but main thing what you have to remember here, if it is available, identify them, find out what for they are using locally nearby my house. It is, we are studying in our subject, so we can identify what is the species change, what is the name of the species. As I told, there is the software which is available in the Android phone, in the Play Store. You can download and take the photograph of the plant, and immediately within few seconds you can know that same picture they will show what type of picture you are comparing, and then they will say this is the botanical source and this is the family, can be easily identified. It will be interesting for you to know. And usage and its chemical constituents can also be seen. According to Ayurvedic pharmacopoeia, Ratalu is a Bengali word, and it is also, and that is Dioscorea bulbifera, Dioscoreaceae. And you see Dioscorea constituents, especially we have to see diosgenin and hecogenin, which we have seen, diosgenin and hecogenin, which we have seen there is 2 lactone rings are present in the 5-membered ring structure of the steroidal ring structure. You can see that 6-membered and 5-membered ring structure is attached with the 6-membered ring structure. That is a structure which you can see here, that is diosgenin and hecogenin. Don't think that there is lot of structure very big, no, very easy. Once you write the phenanthrene derivative with OH group and 2 methyl group and a double bond, only thing is you don't write the side chain of the cholesterol, and write a 5-membered 5-membered lactone ring and a 6-membered lactone ring, CH3, finished, the chapter is over. One double bond O, if you put in the phenanthrene ring structure, then it will become hecogenin, and without double bond O it will become diosgenin. That's all. That is this thing, very simple for you to remember, and once if you write and see, you will never forget. The structure will be always in your mind. Diosgenin means immediately you will write, okay, there is having 2 lactone rings which are 5-membered and 6-membered, finish, CH3. And hecogenin, there is a double bond O in the in the phenanthrene ring structure, that ABC, that is C ring structure. That's all. Very simple. Make it simple while studying chemistry. And steroidal saponin glycoside diosin and its A-glycan is diosgenin. Small quantity of hecogenin is also present. Resin butagenin, alkaloid dioscorin is also present in them. Steroid cholesterol, stigmosterol and p-sterol is also present. Cytosterol is also present. Enzyme sapogenase is also present in the rhizome. So it has more nutrition and very important, and also it has more medicinal value, which is having more use in various ailments. And uses of Dioscorea. Dioscorea is used for rheumatic arthritis treatment, manufacturing of progesterone. Other steroids can also be manufactured by other steroidal groups can be manufactured from this natural compound, and it is contraceptives. Other contraceptives are also prepared from this Dioscorea, and it is used for even asthmatic treatment. So it has many uses in our traditional practice, and which we have discussed. So we are not seeing about this microscopy because it is not in the syllabus, but next drugs like digitalis, licorice, it is necessary for us to study about microscopy and macroscopy. Cultivation collection is also needed apart from that chemical constituents. So you will be seeing in the next class regarding about digitalis and as well as licorice, which are very important drug, about their cultivation, collection, chemical constituents and chemical test and identification, which we have seen here. Even isolations can also be done. Little we have added there, specific thing, specific isolation changes which we want to do, we can remember there. Anyhow, students have to come across always, don't accumulate your subject. Think about that. Every chapter, one chapter coming, it is everything is interlinked. Once you know about the basic metabolic pathway, then only you can go for the structural studies, and we can know that what is present in this structure, what is a triterpenoid, what is the relationship of the sterol, and what is the relationship of cardiac glycosides, what are their type, and these all things which we have discussed are very, very important and also very interesting. Once you go through my material, it will be very useful for you. Thank you for listening. And we have just allied drug. Allied drug. Allied drug means, because these drugs are also very important, just we have seen before, allied drug means they can be substituted in many areas. They are having, even in Kerala we have this deltodia is also there. So we can see Dioscorea esculenta, it is a prickle climber, it is climber tuber with too many stalked produced in branches close to the surface of the ground. The tubers are starchy and free from. Dioscorin is an alkaloid, it is free from alkaloid, it is have some bitter taste, so it is not there in this, but we are interested only in diosgenin, we are interested only in saponin glycoside, it is present, so it is a substituent. You can have a substituent as this one, or allied drug. They have sweet taste, a flavor and mealiness, so it can be taken edible and closely resembles potato, the taste, and the tubers are applied for swelling. Actually, even sometimes if there is a rheumatic swelling, pain, it can be applied. And Dioscorea deltoidea is an extensively climber. It is also a climber and unarmed stem twinned in the left, and the tubers are rich in saponin and are used for washing silk in the cloth manufacturing and the thread area, thread manufacturing, they took washing the silk, wood and hair, and in dyeing, even in the manufacturing of cloth and the manufacturing of fabrics they used to use for dyeing also. They are using this Dioscorea deltoidea. They can kill even lice. They can kill lice for cosmetic purpose. They can use in the lice which is having more lice in the hair, if there is a human being, or in the even for the animals, lice makes many issues. Thus that it can be removed by means of Dioscorea deltoidea. And Dioscorea glabra is a climber in the stem twin to the right. That one is left and this to the right. This species occurs in Assam, Bengal, Bihar, Orissa and Andaman. The tubers are used as a food edible, usually this Dioscorea glabra. So you have done some allied species we have seen for this Dioscorea. So that I am just finishing this as a short class, and next class we will be seeing about detail about the two drugs which comes under in the same chapter. One is digitalis, another one is licorice. We will see the cultivation, collection and their microscopy, macroscopy and their use and their chemical constituents which are present in them, and if there is any chemical test already we have seen here. Apart from that, if there is any extra chemical test or any type of isolation procedure specifically which we have to undergo, and specific uses and application in our traditional practice of Ayurveda and Siddha, this also will be added in the next class. Thank you. Have a great day.